My name is Mike Elram, and I'm with Itential. I'm going to show you how the Itential Automation Platform can be used for an infrastructure as code, cloud network automation use case. First, I'll touch on network innovation. For years, we've seen the data and control plane receive all the attention. Speeds and feeds, better chipsets, the majority of the R&D budget. But what about the management plane? Concepts such as SDN and NFV have been introduced, but they've been slow to be adopted. We envisioned just a couple controllers, but there are lots, such as data center overlay, connectivity, SD-WAN, cloud, and so on. Years ago, we thought we'd teach software to network engineers and networks to software engineers, and we'd be able to get the best of both worlds. What we're suggesting today is to leverage the knowledge of the network engineers and bring them and incorporate the software principles from software engineers that can help, such as source control, test cases, and CI/CD principles. Part of automation is the orchestration of data. That data is best found in their respective source of truth. We also feel your network automation strategy will be made up of multiple controllers. It's about finding the right tool for the right job and being able to orchestrate across them. On our developer site, you'll find a list of open source adapters, so you can connect them into your ecosystem. We've also enabled folks with free tools such as an adapter builder to connect to additional systems, template builders, configuration validators, and so on. The goal is to get more folks participating in automation and enabling them to do so, creating a quicker time to value. It's become evident over the past few years, cloud providers have become a critical part of network infrastructure. Furthermore, IaaS consumers typically leverage more than one cloud provider, but managing shared resources across them is operationally challenging. For our demonstration, we'll be presenting an orchestration and automation use case that shows how Itential can automate the modern network, which is complex and decentralized, all with leveraging the right tool for the right job. Our demo will consist of the Itential platform, leveraging its automation gateway and adapter functionality to connect to Slack for notifications, Netbox for VPC and IPAM inventory, ServiceNow for change management, and Terraform for cloud infrastructure. Once our virtual routers come online, we'll leverage a Git pipeline to validate and test configuration before ultimately deploying it using Itential. I've logged into the Itential platform. Keep in mind that the demo that I'm going to perform is done using the skill sets of a network engineer. It's about dragging and dropping, getting more people to participate in network automation. We're inside the automation catalog. Inside of here, we can expose the automations we create out to the business as networks as a service. We can expose these using RBAC capabilities to limit the access and control usage, as well as integrate those in with our job scheduler so they can be scheduled automations, or expose these out through our northbound API. For today's demonstration, I'm going to run this job manually. Now inside of our demo, I want to show how we can show failures within our Git repository through the commit message and identify how the pipeline can help. So I'm going to go ahead and force a failure before I start this. Here's the job that has just been launched. From an audit perspective, we can see it running. I'm going to click into the workflow builder though and show you how an engineer would actually build this. On the left side of the screen here, we have the different applications and adapters that we have access to. This is made available by the RBAC permissions, and we can see different interactions. These will be the APIs as well as the applications in the platform. If I wanted to make a change, such as add in the VeloCloud interaction here, I can simply expand the list there, drop it onto the canvas, and position it where I'd like in my automation. Zooming in here, you can just see how simple it is for me to make a modification to an existing automation, as well as build new ones. Clicking into the active running, we can see the same view here, but instead this is the execution. So here I can see which tasks have already executed, look at the audit data, see who's worked them and how long they took, finding interesting metrics about my automation. I'm just going to call it a few tasks here. In the beginning, we create a change request. That was the integration into ServiceNow, and part of that routine also involves a process where we send a notification out to Slack, letting us know that a job has started. The diamond icons are used for policies. Those can be rules set up to dictate how the orchestration will occur. As we guide towards the middle of the automation, we see the green boxes that are used for AWS, Azure, and GCP templates. Once we identify the different template that we need, we can then pass the data into the child job that performs the Terraform instantiation. Here we can see the Slack notification that was sent out with the Itential job as well as the ServiceNow change request. This allows users to communicate the automation without having to swivel chair between systems and manually sending out messages. Clicking back into the Itential, I'm going to continue the automation. Inside of the Details tab, I can see a list of tasks needed to be worked. If I click on the Work Task icon here, I'll pull up the View Initialization data from Terraform. I've marked a few of these tasks as manual for this automation, just to show how approvals of data can be progressed. Next task up is the Dry Run task. This will be the preview of configuration changes based on the template that we passed into the Terraform platform. That template was made up of a Jinja template on top of an HCL syntax configuration that was put together through the orchestration with an Itential. Itential went out to the other systems, gathered in the subnet VPC information and other bits of data, passed that into these HCL templates, and again constructed that using Jinja and pushed it into the Terraform platform. Leveraging Terraform is another example of right tool for the right job. It's about understanding that technology changes and the systems we choose to manage networks will continuously evolve. The automation platform must be nimble and flexible, enabling network architects to automate across the best tools for the network. Back into the automation visualization, we can see that we are now completed with the Terraform instantiation and deployment. The CSR has been deployed. We're testing out the CSR to make sure it's online by doing a quick show version against it. Now that that's completed, we're executing another child job here that pushes day one configuration to our Git repository. Inside of GitLab, we can see a new branch has been created called verify config. Once verify config is committed to GitLab, it generates a Git pipeline. Inside of the Git pipeline, we perform a test step which includes test and validate of configuration. This is where you test things for configuration linting, you perform validation tests to ensure that certain interface descriptions meet your company policies, and we do external testing here, such as perform p-cert checks to make sure that our CSR is spun up within a correct, appropriate version that meets our company's policies. Keep in mind, the Git pipeline doesn't replace what network engineers are doing today. Network engineers are building the configuration and deploying it out to the box. We do pre and post checks within our Itential workflow, just like a network engineer would do. The part with the GitLab here and the pipeline is allowing software engineers to help complement the process with network engineers, enhancing the quality of the deployments. Clicking into the test task within the pipeline, we can see the tests that have been executed. And as expected, based on our input, it looks like one of the tests have failed. The interface description did not meet the requirements defined by our company's policy within the test. Going into the verify config branch, I can click into the configuration that was submitted from Itential. Inside of there, we'll pull up the configuration, search for the bad configuration, and make the appropriate changes to match our company's policy. Once I update this interface description with the proper description, we'll go ahead and commit this change, which will invoke a new pipeline. That pipeline is going to retest the configuration. We want to apply as many tests as possible because at any point the configuration could change. So the pipeline is critical to make sure that we have the proper configuration that will be tested against our network deployment. After committing the configuration change in the Git repository, we can see that the test and validation steps have completed in our pipeline successfully. We're now on to the deployed step. Inside of the deployed step, we can see that GitLab has successfully sent a request over to Itential to continue the deployment process. Going through the deployment process here, we're back to a more traditional approach where the network engineering steps occur of a pre-check, deploying the configuration, which will then be followed by a post-check. That completes the demonstration. Thanks for watching how Itential leverages infrastructure as code for cloud networks.